So this is my 100th paper. The paper of the day is the MemSQL Query Optimizer, a modern optimizer for real-time analytics in a distributed database. This paper describes the architecture of the MemSQL Query Optimizer and the design choices and innovations which enable it to quickly produce highly efficient execution plans for complex distributed queries. They discuss how query rewrite decisions oblivious of distribution cost can lead to poor distributed execution plans, and argue that to choose high quality plans in a distributed database, the optimizer needs to be distribution aware in choosing join plans, applying query rewrites, and costing plans. Paper discusses methods to make join enumeration faster and more effective, such as rewrite-based approach to exploit pushy joins in queries involving multiple star schemas without sacrificing optimization time. They demonstrate the effectiveness of the MemSQL optimizer over queries from the TPCH benchmark and a real customer workload. Paper used queries from the well-known TPCH benchmark to investigate the quality of query execution plans generated by the query optimizer by measuring the performance of queries compared to another database and compared to queries generated by MemSQL with some query optimizations disabled, as well as the time required for query optimization. Now let's look at the contributions of the paper. There are three key contributions. The first one is the paper claims that if the cost-based query rewrite component is not aware of distribution cost, then the query optimizer runs the risk of making poor decisions on query rewrites in a distributed setting. They solve the problem in the MemSQL Query Optimizer by calling the enumerator within the rewriter to cost rewritten queries based on its distributed aware cost model. Second, paper enhanced the enumerator to enumerate very fast by extensively pruning the operator order search space. They implement a new heuristic that are distribution aware and use them to prune out states. Third, paper proposes a new algorithm that analyzes the join graph and discovers pushy patterns. That is, it identifies parts of the join graph that could be advantageous to run as pushy joins and applies them as a query rewrite mechanism. Now let's talk PS score. Overall, this paper is a decent read, so it gets 8 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. It's an analysis of an existing system with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is high, so it gets 8 out of 10 on each. Overall PS score is 8 out of 10.